Hello everyone. Good evening everyone. Hi everyone, good evening. Good evening everyone. Hi. I hope all of you are doing well, right? All of you are doing well, right? Good evening, good evening. So, have you guys tried the homeworks? Good evening, Lokesh. Good evening, Neha. Have you guys tried the homework? Homework? Are you able to solve those questions? Huh? Are we able to solve those problems? Today we are going for the next chapter, so we don't have problems starting. We don't have problem. Okay. Good evening everyone. Okay, so in today's class, what we are going to do is, please do try the problems. If you have any trouble, you can Google it also. You know, these days chat GPT and everything is there, so definitely if you're not able to solve something, you can seek the help. Okay, so in today's class, what we are going to do is, we are going to learn the concept of something called as redox reactions, and with the help of redox reactions, so first we learn the redox reactions, and then we will understand something called as oxidation number, and once we understand the oxidation number, we'll go to different types of redox reactions which occurs, and once we have the idea about the different redox reactions, we will go for the balancing of redox reactions. That will be, I think, tomorrow's class. And once we have learned the balancing, I think till Saturday, we'll be doing equivalent weight concept. So it is all very interesting. Okay, I will take you through very interesting concepts. Some of you might be knowing few concepts, not everything. So I'll take you into the chapter of redox reaction and in a very interesting way. And let's see what we can do today. Are we all excited? At least the people who are genuine and serious about the class, serious about their preparation. Are we excited for this? Yes? Okay. Let's dwell into it and let's see what we can understand. Okay, so as somebody has already said that, Harsha, so oxidation and reduction, if you combine them, it is called as redox reaction. So this is reduction, redox, right? Redox reactions. So reduction and oxidation. So this term you see, this term RED, this is nothing but reduction, and OX, if you look into this, this is what? Oxidation. So combined way, reduction and oxidation, they are known as redox reactions. Now you all know there is a very famous reaction which we have studied in our high school, right? Very famous reaction which was a metal displacement reaction. Can you tell me that reaction? There is a very famous metal displacement reaction we have all studied in high school. Do you remember that reaction? I want to start with that reaction. Do you all remember that equation? There is a metal displacement reaction of zinc. What is that reaction? Can anybody give me that reaction? Very, very famous reaction. Metal displacement reaction. What is that reaction? Zinc, yes, zinc plus copper sulfate, right? Zinc plus copper sulfate ka reaction, isn't it? Iron and zinc, no. Copper sulfate and zinc, yes, Solu, very good. So if you remember, our madam taught us this reaction, zinc reaction with copper sulfate, right? So zinc reaction happens with copper sulfate, and what is the product form? Product formed was, bolo beta ji, what is the product? Zinc sulfate and copper was removed. So this is the aqueous solution, this is the aqueous solution, right? And zinc is the solid. So once zinc react with the copper sulfate, in aqueous medium we have copper sulfate and zinc sulfate, and copper become the solid. We all know this reaction, right? Very famous reaction, we all know. Now, how this reaction happens? So, हमारी मैडम ने क्या बोला? और मैडम told us that zinc is a more reactive metal in comparison to the copper, right? Cu2 plus. So, it will replace copper and it will form the zinc sulfate ka solution, right? Now, so this concept can be very beautifully explained, you know. This reaction, I'll tell you, this reaction is the basis of something called as electrochemistry chapter. This reaction is the basis to understand galvanic cell. This reaction is the basis to understand battery, to understand all the kinds of cell, to understand fuel cell, you know. So it helps a lot according to reactivity series, right? But this reactivity series, how this reactivity series is formed, evolves into a chapter which is known as electrochemistry chapter. So Daniel cell, right? Yes. So galvanic cell ka one specific example is the Daniel cell. Some of you might be knowing. So zinc plus copper sulfate, giving zinc sulfate plus copper sulfate. Okay. So anyways, so very interesting reaction we are having. Now let us dwell to this. Now to understand this reaction, I need to understand something which is called as oxidation and what is called as reduction. To understand this reaction, I need to understand what is oxidation and what is reduction. You all have studied what is oxidation. So we all have studied oxidation is nothing but, sir, this is loss of electron. So from any given atom or ion, if we lose electron, that is called as oxidation, right? And what is reduction? Reduction is called as gain of electron. Reduction is called as gain of electron to any given atom or ion, right? So this is very basic definition. Addition of oxygen also, Samir will come to that. Now, that is a very interesting point. For now, loss of electron and gain of electron. Okay, so most of you are saying that it is addition of oxygen and removal of oxygen. Let me come to that also. So, but the basic definition is oxidation means loss of electron, reduction means gain of electron. Nobody should get confused. What I mean by this is, let me say that there is a shortcut in every book. It is written oil rig. Oil rig, container, big containers of oil. Oil rig. What is oil rig? Oxidation. O means oxidation. Oxidation is, what is oxidation? Oxidation is loss of electron. Oh, this is very simple shortcut, right? Oil rig. Oxidation is loss of electron. Okay, let me come to this page. Oil rig. What is oil rig? Oil rig में देखो बेटा जी, very simply oxidation. Oxidation means oxidation is loss of electron. Oxidation is loss of electron. Reduction is gain of electron. Reduction is G for gain of electron, right? Gain of electron. Now through this help, oil rig, gain of electron and loss of electron. Now I can explain you all that concept which you have studied. Gain of oxygen, loss of oxygen, gain of hydrogen, removal of hydrogen. Everything could be explained with this one concept, which is loss of electron and gain of electron. Now let us come to this. So if you look into this example, what is the oxidation number on the zinc? For now, oxidation number, you think like the charge. So for now, the charge on zinc is 0, right? And what is the charge on copper? So sulfate being -2, the compound has to be neutral. So the charge on copper will be, of course, what below? +2. Charge on copper will be +2. Now you see, here zinc contains 0 charge and zinc converts into what below? Sulfate is again -2. So zinc has to become +2. That is how they will be neutral, isn't it, beta ji? So what happened is, you see, zinc has been converted into Zn2 plus. Zinc has been converted into Zn2 plus. If it has been converted into 2 plus, definitely we have learnt in the initial classes, it has to lose 2 electrons. Because the zinc atomic number is 30, so 30 proton and 30 electron, we don't touch the nucleus to create any charges. What we do, to create the negative charge, we add electron. To create positive charge, we remove electron. We don't touch the proton because it is a nucleus, and I told you, you'll have a nuclear bomb, right? If you do anything with the nucleus, right? So Zn converts to Zn2 plus, it must have lost 2 electron. So this process becomes what below? oxidation. This process is what bolo beta ji? Oxidation. Now what is reduction? Oxidation means loss of electron. You see zinc has lost 2 electrons. What is happening in case of reduction? Now you see copper. Copper contains what charge bolo beta ji? 2 plus charge. And because the zinc has lost 2 electrons, these 2 electrons, where they will go? Where this electron is going? So that electron will be accepted by Cu2 plus and this will be converted to copper. So initially this was in aqueous medium, it has been converted to solid medium. So what happened, sir? What happened is in oxidation, loss of electron happened, and in reduction, gain of electron happened. In oxidation, loss of electron happened, and in reduction, gain of electron happened. That is the more precise definition. That is the more precise definition of the oxidation reduction. But you all are saying, sir, it could be oxidation means oxygen. Oxidation means oxygen. That is how that term has come. Let us come to that also. If I take another example, okay, you all remember this shortcut, okay, oil rig, I am removing this for now. So, let me take one more example. Let us say zinc reacts with half mole of oxygen, right? Zinc reacts with half mole of oxygen. The product formed is zinc oxide. Wow. The product formed is zinc oxide. Very good. Now what has happened, sir? What has happened? If you look at the oxygen, oxygen is a neutral atom. Oxygen is a neutral atom, or you can call element rather. So oxygen is a neutral element. What is the charge on oxygen? 0. So charge on oxygen is 0, right? 0. Now, according to you, the definition is, what is the oxidation? Gain of oxygen. So basically, either you say gain of oxygen or you say loss of electron, both are same. Let me connect to that. So you see, zinc reacts with oxygen to form zinc oxide. What has happened? If you look at the reaction, oxidation reaction, let me look at the oxidation reaction. So what happened in oxidation is, beta ji, zinc contains, what is the charge on zinc? 0. Now zinc has been converted into zinc oxide. We all know that oxygen ka electronic configuration is 2s2, 2p4, right? Now to complete the octet, it gains 2 electron. Because it gains 2 electron, it becomes 2p6. And because it is gaining electron, it will become -2. That means this is -2 and this is +2. And if you do the crisscross, this is Zn2O2. And what is the simplest formula? Zinc oxide. 2 will be cancelled out, right? So what is happening over here? This is gain of oxygen. What is this? This is gain of oxygen, right? So what happened is zinc converted into Zn2+. Ab dekhiye, zinc goes to Zn2+. And to go to Zn2+, it must have lost 2 electrons, isn't it? It must have lost 2 electrons. Okay. What about reduction now? You look at the reduction. So what is reduction? Half mole of oxygen gains how many electron, beta ji? 2 electron. Half mole matlab single oxygen. Gains 2 electron, and from 0 oxidation number, it becomes O-2. You see, it becomes O-2. So this reaction is reduction and this is oxidation. So what is oxidation? Oxidation is loss of electron. What is reduction? Gain of electron. Or what you are saying is zinc oxidation means zinc should add oxygen. Oxidation means what? Oxygen ka addition, right? You see, oxygen has been added. But the more precise definition, because not always you will have oxygen. Without oxygen also you can do the oxidation. Without oxygen also you can do the oxidation. The concept is it should go for the oxidation. The concept is it should increase the charge. Plus charge should increase. So from here, 0 charge, it has been converted to +2 charge. And oxygen, which was 0, has been converted to -2. So gain of electron becomes reduction and loss of electrons become oxidation, and that is how reduction oxidation entirely, if I'll add the equation, Zn plus half O2, if I'll add the equation, Zn plus half O2, electron cancelled out, this becomes Zn2 plus O2 minus. And we all know that both are charges, right? Both are charges. They cannot live away from each other. Because they are charges, they will come together and they will form zinc oxide. They will form zinc oxide. So what is oxidation? Oxidation is loss of electron. What is reduction? Gain of electron. You always remember this shortcut, oil rig. We always remember this shortcut, oil rig. Oxidation is loss, reduction is gain. Reduction is gain. Okay. I hope, sir, oxidation is also the loss of hydrogen atoms. That also I can explain. That also I can explain to you. Okay, for now, but the basic idea, you see, hydrogen, oxygen, don't stick to these things. Definitely, the oxidation terms come from the oxygen. The oxidation term has come from the concept of oxygen only. But it is not true that in every reaction you have the oxygen. For example, if you look into this reaction, the last reaction, zinc plus copper sulfate. What happened to zinc? Zinc का तो we have done oxidation, right? You see, zinc का तो oxidation किया ना बेटा, हमने किया ना zinc oxidation. But do we have any oxygen with the zinc? Do we have any oxygen with the zinc? No. So that is not the logic. Logic is, yes, it relates with the activity series. We are coming to that. For now, wait for some time. Let me move ahead. I'll explain you every concept. Don't worry. Everything will be there. Once I have not said anything, then you ask your doubt. Okay. So zinc is not having any oxygen, but still this is oxidation. Why? Because the logic is oxidation means oxygen, and once an atom is connected to oxygen, of course positive charge will increase. Let us say I'm an atom, my charge is 0. My charge is 0. If you attach one oxygen atom, let us say I'm the atom A. I'm atom A, and you attach, I'm neutral atom. But if you attach one oxygen, this is oxidation. You try to understand what I'm saying. This is a very beautiful thing. So once you attach oxygen, what is happening? Base में क्या हो रहा है? Try to understand the logic. What is happening? Once oxygen comes, oxygen will have -2 charge and A will become +2. That means what happened? Loss of electron for A. So whenever oxygen atom will be connected to any other atom, that particular atom through which oxygen is attaching, that atom ka plus charge will increase. That means it will lose electron. That electron will go to what? Oxygen. Therefore, it is having oxidation. That is how the term oxidation comes. So any atom, once it connects to oxygen, what happens? Naturally, it loses electrons and it becomes oxidized. That is the whole thing. I hope you all understand. Is this concept clear to everyone? Just give me a thumbs up. Let me see how many of you have understood what I'm saying. What I just now said, is it clear to everyone what I'm saying? Very beautiful concept though. Is it clear to everyone? What I just now said, is it clear to everyone? Great. Great. Okay. So oxidation means loss of electron and reduction means gain of electron. So this is the basic idea. I will come to the hydrogen also. Okay. Now to understand the redox reaction, to understand different types of redox reaction, we need to understand something which is called as oxidation number. We have to understand something called as oxidation. Achha, before that, one more thing. There are two terms used. One is called as half cell reaction. One is called as half cell reaction, and one is called as full cell reaction. These are the terms which are thoroughly used. Half cell reaction and full cell reaction. What is half cell reaction? Any reaction in which there is presence of electron. There is presence of electron. There is presence of electron. Right? There is presence of electron. For example, I'll take the same example. Okay. Let us say that I'm having this one. Okay. Let me take this example, beta ji. मैं बोलता हूँ कि zinc plus copper sulfate giving ZnSO4 plus copper. In this one, we don't have electron, right? Now the definition says that half cell reaction is that reaction in which there is presence of electron. There is presence of electron. Now let me come to that. This is not a half cell reaction. This is actually full cell reaction. This is actually which reaction? Full cell. Full cell reaction means that redox reaction which do not contain electron. Which do not contain electron in reaction. Which do not contain electron in reaction. So you see, this is 0, converted to +2, loss of electron, oxidation happened. this was plus 2, this has been converted to 0, so this is reduction and this is oxidation, right? So definitely oxidation is happening, reduction is happening, so this is a redox reaction. But which kind of redox reaction? Is it a full cell half reaction? Is it a full cell half reaction or half cell half reaction? So this is a full cell reaction because in the reaction there is no electron. In the reaction there is no electron. Now if I write anode, zinc anode, oxidation basically, anode actually oxidation. Anyways, so zinc gives what? Zn2 plus 2 electron. Now this is a half cell reaction. Similarly, Cu2 plus 2 electron converts into Cu. This is oxidation and this one is reduction, right? And so these reactions are known as half cell reactions. They are known as what, bolo beta ji? Half cell reactions. They are known as half cell reaction. So what is half cell reaction? It is that reaction in which there is presence of electron. You see, there is electron in the reaction, there is electron in the reaction. But if you write the full cell, so Zn add kar do, electron cancel hoga. So Zn Cu2 plus giving what, bolo beta ji? Copper plus Zn2 plus. In this reaction, we don't have any electron. In this reaction, we don't have any electron. Therefore, this is called as full cell reaction. Therefore, it is called as full cell. What is full cell? What is full cell? In which there is no presence of electron. What is half cell? In which there is presence of electron. What I mean is, if you remember the Daniell cell, if you remember beta ji Daniell cell, I don't know how many of you remember. If you remember the Daniell cell, what happened is, this was the zinc dipped in zinc sulfate solution, connected with the voltmeter, and this is copper sulfate solution, this is copper electrode. Yes or no? So this was which electrode, bolo beta ji? Copper. This was which electrode, bolo beta ji? Zinc. Dipped in with solution ZnSO4 and dipped in with solution copper sulfate. If you remember the Daniell cell, what happens in this one, if you remember, if you don't know, it's okay, fine with me. So zinc loses electron in this one, here, zinc loses electron and becomes Zn2 plus, which will come to the solution. Zn2 plus will come to the solution. Now, these two electrons are flowing. Now, if I remove this one, beta ji, if I remove this particular cell, there is electron, right? So this is half cell. But if I allow the electron to flow, now electron in the solution we are having Cu2 plus. So this Cu2 plus will accept these two electrons and convert into copper. So what happened? Zinc loses electrons and these electrons has been accepted by Cu2 plus. So now there is a full cell. Voltage has come. It is a full cell, right? So in full cell, if I add two equations, in the full cell, we don't have any electrons. This is a full cell. What is half cell? You take only one. So either reduction is happening or oxidation is happening. Is this clear to everyone? Half cell, full cell ka concept. Is this clear to everyone? Just give me a thumbs up, guys. Quickly. Let's go to the next topic. Is this clear to everyone? What is half cell, full cell? Is it clear to everyone? Bolo beta ji. Half cell, full cell clear? Okay. Okay. Theek. Now, we are coming to the concept of oxidation number. Now, to understand different types of redox reaction, it is very important that we understand oxidation number. So, what is oxidation number? I'm telling you a very interesting concept. Listen carefully. You'll enjoy it. You'll love it. Listen. An atom's oxidation number, also called oxidation state. So please remember, either it will be called as oxidation number or sometimes it is called as oxidation state. Either it is sometimes called as oxidation number or sometimes this is known as oxidation state. This signifies the number of charges. What it signifies? Number of charges the atom would have in a molecule or an ionic compound if electrons were transferred completely. Very, very interesting. This definition is very interesting. Let us focus on this statement. This statement says that whether you have an ionic compound, let me take one example. Whether you have an ionic compound or let us say we are having a covalent compound. We all know HCl is a covalent compound and NaCl is an ionic compound. Now, according to the definition, what is the oxidation number or oxidation state? It is the charge on atom. It is the charge on atom, right, would have in a molecule. So number of charges the atom would have in a molecule or an ionic compound if electrons were transferred completely. What it means is transfer completely. if transferred completely, right? If transferred completely. What I mean is, listen British, ध्यान से सुनिए. Let us take NaNCl. We all know that Na donates 1 electron to chlorine. So this is a complete transfer, right? So this is a complete transfer. So what is the compound now? Na plus and Cl minus. So what is the oxidation number? Oxidation number for sodium is +1 and oxidation number for chlorine is -1. Oxidation number for chlorine is -1. Oxidation number of sodium is +1. But if I take the compound hydrogen chloride, it is a covalent compound, right? It is a covalent compound. And in covalent compound, there is no transfer of electron, there is sharing of electron, right? There is sharing of electron, isn't it? Now, there is sharing of electron. So how come charge will come, sir? How do I know what charge will come? Now comes the concept of electronegativity. Hydrogen is in the extreme left of the periodic table. Chlorine is in the extreme right of the periodic table. We have studied in the last class that as we move left to right into the periodic table, effective nuclear charge increases. Left to right into the periodic table, effective nuclear charge increases, and therefore electronegativity increases. And because electronegativity increases, what I told you, that this will become partial minus and this will become partial plus. So although complete electron has not been transferred, but definitely in the direction of chlorine, electron has moved. Not completely, partially, but it has moved. So that is the concept of oxidation number. Oxidation number or oxidation state does not mean that there should be complete transfer. Even if there is partial transfer, whatever charge occurs, we take that. So because there is a single bond, this will be -1 and this will be +1. Very interesting, sir. If let us say we are having a double bond, let us say मान लो carbon double bond oxidation. Let us say we are having carbon double bond oxidation. Now, which one is more electronegative, oxygen or carbon? Give me. Bolo beta ji, which one is more electronegative, oxygen or carbon? Which one is more electronegative, oxygen or carbon? More electronegative atom, oxygen or carbon? More electronegative atom, carbon or oxygen? Give me. Oxygen, right? Oxygen, very good. So now, oxygen will contain with charge partial minus and carbon will contain with charge partial plus. Oxygen will contain partial minus, carbon will contain partial plus. Now what is the oxidation number? What is the oxidation number? इधर देखो बेटा जी, मान लीजिए एक कंपाउंड लिया CH3OH, this is alcohol, and one compound I am taking which is known as aldehyde. Let us say, I think all of you know aldehyde, CH3CHO, right? CH3CHO. Now listen very, very carefully. What is the oxidation number, sir? Tell me the oxidation number. देखो बेटा जी, look at the oxidation number. So oxidation number for carbon and oxygen. You look at oxygen. Because see, if I, for now, I don't want to confuse you for the total charge. अभी के लिए भूल जाओ. Forget about hydrogen. Forget about hydrogen. Let us say we are having carbon oxygen single bond. We are having carbon oxygen single bond. So this will be -1 and this will be +1, right? But if you have a double bond, let us say we are having a double bond, C double bond O. Now in double bond, this is partial minus and this is partial plus. Now this 1 electron, 2 electron and then 4 electron, right? So now 2 electrons are getting transferred to our oxygen. How many electrons are getting? 2 electron. Total to 4 hai na beta ji. So in this bond, from this bond 1 electron moves towards here and from here 2. 1 and 2. So what will be the oxidation number? -2. What will be oxidation number? +2. Similarly, let us say if I have carbon triple bond nitrogen. Carbon triple bond nitrogen. So what is the oxidation number of nitrogen? Bolo beta ji. What is the oxidation number of nitrogen? Give me the value. What is the oxidation number of nitrogen? What is the oxidation number of nitrogen in C triple bond N? What is the oxidation number of nitrogen? Very good, -3. Very, very good beta ji. Very, very good. So this is -3. So carbon is partial plus, nitrogen is partial minus. So this will be carbon +3 and nitrogen will be -3. So let us come to the definition. What definition says that an atom's oxidation number called oxidation state signifies the number of charges the atom would have in a molecule. Would have. Not exactly it is having. but would have. That means nitrogen here is not having -3 charge. It is not -3 charge. Please remember, this is not -3 charge. तो मतलब कूलम हो गया ना बेटा जी, -3. That is the coulomb charge. It is not charge. It is not charge. If it was nitrogen, it will have -3. If it was carbon in this form, it will have +3. Not exactly having, but it would have in a molecule or in an ionic compound. So if you have an ionic compound, nitrogen will have -3, something like that. Okay. If electrons are transferred completely. सबको समझ आया? Is not carbon plus minus? Yes, carbon is plus minus both. It can gain 4 electron, it can lose 4 electron. It can become +4 as well as it can become -4. I'm coming to that, beta ji. I'm coming to that. Don't worry. Is this concept clear to everyone? Is this concept clear to everyone? Let me go to the next one now. Is this concept clear to everyone? Bolo beta ji. Is this concept clear to everyone? Now we are going to learn how to calculate the oxidation number with the help of rules. With the help of what, bolo beta ji? Rules. And then I'll come to all the calculation of oxidation number, okay? Then I'll come to all the calculation of oxidation number. Does this reaction relate with organic chemistry? Yes. That is why I'm going in more detail, so that you can correlate. Very good question, Harsha. Definitely it is related, and it gives a lot of clarity. It gives a lot of clarity, okay? Oxidation number rules. So we use the following rules to assign oxidation number. We use the following rules to assign oxidation number. What is the first one? In free elements. Free element matlab what? Oxygen, nitrogen, carbon, something like that. So in the case of free elements, that is the uncombined state. Uncombined state, each atom has an oxidation number of 0. So if atom is in free state, for example, carbon, graphite, right? Carbon exists in form of graphite, right? Electron. So what is the charge? Charge is 0. So if atom is in free state, oxidation number will be 0. Thus, each element atom in hydrogen, if you look at the bond, right? Hydrogen. Do we have any electronegativity difference? No, sir. There is no electronegativity difference because the atom is same. So charge will be 0 and 0. Right? So same atomic, sodium, beryllium, potassium, oxygen. O double bond oxygen, right? What the oxidation number? 0 and 0. Because there is no charge. Why there is no charge? Because there is no electronegativity difference, isn't it? P4, 4 phosphorus, that is how the structure is being formed. I'm not going into the structure, leave it. So single atom, if it is in unbonded state or same kind of atom, the oxidation number considered is 0. Oxidation number considered is 0. Okay. Going to the next rule now. For ions composed of only one atom, that is monoatomic ions. What are monoatomic ions? जैसे बेटा जी इधर देखो Cl minus, fluoride ion, monoatomic. Nitrogen containing 3 minus, oxygen containing 2 minus. If you remember, I have already told you monoatomic and polyatomic. Okay. So for ions composed only of atom, that is monoatomic, the oxidation number is equal to the charge on the ion. So what is the oxidation number? Charge on the ion. For example, Cl contains -1. So what is the oxidation number? -1. Thus, Li plus ion has an oxidation number of +1, right? Br2 plus ion +2, Fe3 plus ion +3 oxidation number, iodide ion -1 oxidation number, O2 minus ion -2. So if it is monoatomic, if it is which atomic bolo beta ji? Monoatomic, the charge itself will become the oxidation number. The charge itself will become the oxidation number. Okay. All alkali metals. We all know that alkali metals matlab lithium, sodium, potassium. We know that a valence shell contains 1 electron. Therefore, to complete the octet, they lose 1 electron and they become what? Na plus, lithium plus. So they will have oxidation number +1. Alkaline earth metals, bolo beta ji, magnesium, calcium, they remove 2 electron to have completion of octet. Therefore, for all the alkaline earth metal, charge will be +2. So what will be oxidation number? +2. Fe +2, yes sir. Definitely, Neha, definitely. +2 is also possible, +3 is also possible. If you have, let us say, compound FeCl2 and FeCl3, right? So in the case of FeCl3 oxidation number +3, in the case of FeCl2 oxidation number +2. What is the oxidation number of chlorine? -1. Oxidation number, single atom. Okay. Okay, so plus 2 in the aluminium. Aluminium contains what charge? Outermost electron 3. It will remove 3 electrons to complete the octet. So this will be plus 3. Third rule. So this is rule number 1. Element in the free state or same atom, right? So oxidation number 0. And if it is monoatomic, either it is cation or anion, monoatomic, it will have whatever charge, that will be its oxidation number. Okay, come to this one. The oxidation number of oxygen in most of the compounds is -2, but in hydrogen peroxide, अच्छा देखो ये समझाता हूँ मैं, देखिए. So magnesium oxide, calcium oxide, and then hydrogen peroxide. This is hydrogen peroxide. Do I have vacant page? Okay, इधर समझाता हूँ बेटा, देखिए. So let us say I'm having magnesium oxide, or I'm having what? Sodium oxide, or I'm having hydrogen peroxide. Why this is called as peroxide? I'm explaining to you. Listen carefully. So what is the charge on magnesium? +2, sir. So what is the oxidation number on magnesium? +2. What is the oxidation number on oxygen? -2. Because we all know oxygen needs 2 electrons to complete the octet. Similarly in sodium oxide, Na2O, what is the oxidation number of sodium? +1. How many sodium? 2. So what is the oxidation number on oxygen? -2. But in case of hydrogen peroxide, what is the oxidation number? In the case of hydrogen peroxide, how we calculate the oxidation number? So there is a method called as X method. क्या बोलते हैं बोलो बेटा जी? X method. What is the X method? X method means, let us say I don't know the oxidation number of oxygen. I don't know what is the oxidation number of oxygen. Abhi I'll solve so many questions by X method. If I don't know the oxidation number, make it X. So how many oxygen? 2. So this is 2X, right? Plus, what is the oxidation number on hydrogen? We all know hydrogen is generally H+. Hydrogen is generally H+. In some cases, it might be H-, but H-, I'll tell you that rule. So hydrogen will be -1 only with metals. Only with what, bolo beta ji? Metals. Hydrogen will be -1 only with the metals, because metals are more electropositive. So they want to donate the electron. So hydrogen will become -1. So hydrogen is -1 only with case of bolo beta ji metals. याद रखिए please. Hydrogen is -1 only with the metals. Otherwise it will be +1, because hydrogen जैसे HCl, H plus Cl minus है कि नहीं? So hydrogen +1 -1. Why it happens is hydrogen का electronegativity is very very less. Hydrogen का electronegativity very very less. So it becomes +1. But metals का electronegativity is least. Metals का hydrogen amphoteric नहीं बेटा जी. Metals का electronegativity is very very less. Why? Because the metal has a tendency to donate, not to accept. And what are the definition of electronegativity? Electronegativity means to accept the electron, and metal has the tendency to donate the electron. So metal का electronegativity very less. So whenever hydrogen will be bonded with the metal, I think there is a rule. You'll study this rule is there. Generally +1. So 2x plus hydrogen पे +1. So +1 into 2, right? +1. So this is equal to 0 because the compound is neutral. Total charge will be equal to 0 because the compound is neutral. So this is 2x is equal to what? -2. So x is equal to -1. Oh my God. ऑक्सीजन का ऑक्सीडेशन नंबर क्या आ गया? -1. ऑक्सीजन का ऑक्सीडेशन नंबर क्या आ गया? -1. But generally, compared to oxygen, hydrogen having less electronegativity. Yes, hydrogen have less electronegativity in comparison to oxygen. So 2x hydrogen extreme left, and according to first rule, hydrogen oxidation number is 0. No sir. Which rule? नहीं अभी ये फ्री नहीं है. आई एम सेइंग लिथियम हाइड्राइड बेटा जी, लिथियम हाइड्राइड. इन दैट केस, सो दिस इज अ मेटल एंड हाइड्रोजन. सो मेटल विल हैव +1, and hydrogen will have -1. I'm not, this is free. Once it is free, no charge. I'm talking metal hydride. They say lithium hydride. So then metal will be +1, this will be -1. And when it is bonded with the extreme right, oxygen more electronegative, then it will be minus. Plus, hydrogen will be plus. So 2x is equal to -2, x is equal to -1. I can prove you how to prove it. इधर देखो. So this is the structure of hydrogen peroxide. Not exact, but this is how you represent. So what is the electronegativity between hydrogen and oxygen? Oxygen is more electronegative, right? Single bond. So -1, and this will be +1, isn't it? Now oxygen का electronegativity same, oxygen का electronegativity same, therefore due to these oxygen no charge. But this oxygen is bonded with hydrogen +1, oxygen -1. So oxygen का oxidation state क्या हो गया? -1. It is not -2, it is -1. So if you know the structure, basically you'll study structure in chemical bonding chapter. Once you get to know the structure, you can predict oxidation number just like a snap. To know the structure, you need to understand bonding chapter, which will come later. For now, we are doing it very simply, okay? So what is the next rule? Fluorine has an oxidation number of -1. So all the halides will have oxidation number 1. Ye dekho, rule number 4. The oxidation number of hydrogen is +1. This rule you have to memorize. Oxidation number of hydrogen is +1. If you understand the logic, no need to memorize. It is all for those who don't understand the logics. So hydrogen oxidation number generally +1, except when it is bonded with metals. Except when it is bonded with the metals. For example, lithium hydride, sodium, because metal being more electropositive, hydrogen more electronegative. Hydrogen is electropositive generally, but in the case of metals, it will become electronegative. So lithium hydride, sodium hydride -1, +1, calcium +2, 2 hydrogen, 1 hydrogen will have -1, like that, okay? All the halides will have -1. In a neutral molecule, the sum of the oxidation numbers of all the atoms must be 0. And that is how I have done this. You see, oxidation number ka sum should be equal to 0 because the compound is a neutral compound. Okay? In a polyatomic ion, the sum of the oxidation numbers of all the elements in the ion must be equal to the net charge of the ion. Okay, I'll explain this concept to you. Okay. Now let me come to this. I'll tell you how to check the oxidation numbers. Very easily I'm telling you, please remember. Oxidation number, how to check. देखो बेटा, बहुत सिंपल तरीके से बताता हूँ आपको. Very simple way. Sir, why does some elements show variable valencies? Because I'll come to that. Variable valency, I'll come to that. Okay, I'll come to zombie, I'll come to that. Variable valency, because they say iron shows +2 as well as +3, because in both electronic configuration it has some amount of stability. Because of its stability, it will show. That will be taught in D block chapter. I can't go more in detail, but just remember for now, it will be stable in both the oxidation numbers. Okay. How to calculate the oxidation number? Let us start. Hydrogen के नीचे lithium, sodium, potassium, right? Now hydrogen इधर क्या आता है बोलो जी helium, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, isn't it? Then what comes sodium? Sodium, potassium, rubidium. Oh, what I'm writing. Sodium के बाद क्या आता है बोलो बेटा जी calcium, right? Sodium, calcium. इधर देखो. So if you look into these periodic tables, ध्यान सुनना बेटा जी. This is group 1. If you remember periodic table high school class, this is group 1. And this one is group 18, isn't it? This is group 18. If you look into this, what is the minimum oxidation number and what is the maximum oxidation number? What is minimum oxidation number and what is maximum oxidation number possible? ध्यान से सुनना बेटा जी. Listen very carefully. Sodium, magnesium, sorry. So, minimum oxidation number and maximum oxidation number, okay? Now, what is the minimum oxidation number? So, you just find out the valence electron. Find out the valence electron. Let me take one example and I'll write the formula. For example, let us say we are having nitrogen. What we are having? Nitrogen. Now, what is the nitrogen ka minimum? What is the nitrogen ka valence electron? We all know the configuration. This is what below 1s2, 2s2, and below beta G 2p3. Isn't it? This is the configuration of nitrogen. So second cell is the valence cell. So what is the number of valence electrons? Valence electrons is equal to 5. Valence electron is equal to 5. So how many electron nitrogen can remove? All the valence electron. Now you'll ask, sir, is it possible nitrogen can remove 5 electrons? Yes, it can. It can. You'll see the compounds. It is possible. To complete the octet, it can remove the 5 electrons. Not exactly. See, I'm not saying it is going to remove all the electron because it is going to form the covalent compound. It is not going to form the ionic compound that it has to remove all the electron. Remember the definition of oxidation number? Not exactly it is transferring electron, but it appears like it is transferring electron. Appears like, not exactly, appears like. I hope this is clear to every one of you. So 5 is the valence electron, okay? So maximum oxidation number, if it loses all the 5 electron, what is the oxidation number? Plus 5. Now, what is minimum oxidation number? Minimum oxidation number is equal to 8 minus valence electron. Minimum, I'm talking about the second period, I'm talking about second period. Minimum oxidation number is equal to 8 minus valence electron. What is 8 minus valence electron? Number of valence electron 5. So for nitrogen, sorry, valence electron minus 8. Valence electron minus 8. So this will be valence electron minus 8. So 5 minus 8 is equal to minus 3. That means nitrogen ka minimum oxidation number minus 3 and maximum oxidation number plus 5. I can take more examples. Let us say I'm talking about which atom, you tell me any atom, carbon. Let us talk about the carbon. So what is the carbon ka valence electron? What is the carbon ka valence electron? Carbon ka valence electron is equal to 4. So what is minimum oxidation number? Minimum oxidation number and maximum. Maximum is the number of valence electron. Maximum oxidation number is the number of valence electron. What is the number of valence electron? 4. So this will be plus 4. What is the minimum? 4 minus 8. Valence electron minus 8. What it is? Minus 4. What it is? Minus 4. Now you may have doubt. Sir, can you prove me? Can you prove me this is plus 4 minus 4 possible? Yes, I can prove you. Let me take one example. Let us say I'm having compound CH4 and CCl4. CH4 and CCl4. Now, I want to ask all of you, see, which one is more electronegative, carbon or hydrogen? Which one is more electronegative, carbon or hydrogen? Which is more electronegative, carbon or hydrogen? Which one is more electronegative, carbon or hydrogen? Left to right, electronegativity increases. Which one is more electronegative, carbon or hydrogen? Carbon. Very good. Carbon. Hydrogen कैसे हो गया बेका? Anuradha, how it is possible, beta ji? Carbon. Left to right, electronegativity increases. So carbon is more electronegative, right? So if you draw the structure, hydrogen plus 1, less electronegative, hydrogen plus 1, hydrogen plus 1. So due to every bond, carbon will have minus 1, so carbon is minus 4. Come to the CCl4. Now, which one is more electronegative? Chlorine or carbon? Which one is more electronegative? Chlorine or carbon? Which one is more electronegative? Chlorine or carbon? Chlorine, right? Chlorine. So chlorine will have minus 1, single bond. Single bond, that means only one electron will get transferred. So minus 1, minus 1, minus 1, minus 1. Due to every minus, plus 1, plus 1, plus 1 and plus 1. So what is the total charge? Plus 4. And what is the minimum? Minus 4, right? You can solve by the X method. We can solve by the X method. The valence is applicable only for second. No, it is applicable for third as well. I'll come to that. For now, let us stick to this one. Now, X method, by X method. So what is X method? Carbon I don't know, so carbon is X. Hydrogen. Hydrogen contains plus 1 always, except when hydrogen is bonded with metal. Except when hydrogen is bonded with the metal. Rule याद रखना पड़ेगा, rule. So X plus how many hydrogen? 4. And charge plus 1. Is equal to 0. Total charge is equal to 0. तो क्या आ गया? X plus 4 is equal to 0. X is equal to कितना आ गया? Minus 4. X is equal to minus 4. So you can solve with the help of bond as well as X method. We can solve with the help of bonds as well as X method. Okay. Come to this one. Carbon I don't know. Let us say this is X. Carbon is X. Chlorine. As I have discussed just now, all the halogens have minus 1. All the halogens have minus 1. More electronegative. See, that is why I taught you electronegativity ka concept. Electronegativity will have minus, electropositivity will have plus. As simple as that. Ammonia also, I am discussing ammonia better. Wait karo. So X minus plus, what is the charge? Minus 1 into how many? 4 atoms is equal to 0. Total charge should be 0. So X is equal to kitna ho gaya? Plus 4. So you can solve by the X method as well as bond method. Come to ammonia. Somebody said ammonia, sir. Take the example of ammonia. Okay, I'm having ammonia. ammonia and NCl3. Ammonia and NCl3. Can you give me the oxidation number of ammonia? Can you give me the oxidation number of nitrogen in ammonia? Nitrogen in ammonia oxidation number and nitrogen in NCl3. बोलो बेटा जी, ammonia में oxidation number. What is the oxidation number of nitrogen in ammonia? Give me that. +3, -3, what it is? In case of ammonia, -3. Very good, all of you. Very good. Very good. So, X method. Nitrogen X. Hydrogen पे +1. So, +1 into 3. +3 is equal to 0. X is equal to -3. And what is NCl3? Give me for NCl3, beta ji. Give me for NCl3. For NCl3, nitrogen oxidation number. NCl3. NCl3 में नाइट्रोजन का ऑक्सीडेशन नंबर -3 बोथ आर -3 3 प्लस प्रणवी वेरी गुड बेटा जी वेरी गुड +3 -3 बोथ -3 हाउ इज इट पॉसिबल +3 देखो मैं बताता हूं इधर देखिए सो लेट अस लुक एट द स्ट्रक्चर नाइट्रोजन हैव 5 valence electron. If I'll go to the structure, you'll get confused. So there is something called as lone pair. So anyways, it is having how many bonds? 3 bonds. Lone pair भी होता है. Forget about that. Forget the lone pair. Simple. So hydrogen +1, +1, +1. Nitrogen more electronegative. -1, -1, -1. Total -3. If you look at this, chlorine, chlorine, chlorine. Lone pair होता है. Forget the lone pair. Forget about lone pair. Leave the lone pair. Chlorine more electronegative because chlorine is on the right side of the periodic table, right? So chlorine -1, -1, -1. Nitrogen +1, +1, +1. कितना हो गया? +3. Or you can solve by the X method. X method is actually more simple. To apply the X method, you need to remember the rules. To apply the X method, you need to remember all the rules. To apply the X method, you need to remember the rules. Okay? Chalo. I'll take few more examples just to make you understand. Let us take few more examples. Find out sulfuric acid. Sulfuric acid में what is the oxidation number of sulfur? Oxidation number of sulfur in sulfuric acid. Give me the value. Oxidation number of sulfur in sulfuric acid. Oxidation number of sulfur in sulfuric acid. -6. Is it so? -6. 6. Very good. 6. +6. Very good, very good. Anuradha, very good. How somebody is calculating -6? I don't understand. Hydrogen. So hydrogen, 2 atoms. What is the charge? +1. Hydrogen, if it is only bonded with metal, you all know what is metals. If it is bonded with metal, -1. Otherwise, +1. Plus sulfur, I don't know X. What is the number of sulfur? 1. So X into 1. Plus how many oxygen? 4. And what is the charge on oxygen? Charge on oxygen is the -2. So this is -2. And total should be equal to 0 because the compound is neutral. So 2 plus X minus 8 is equal to 0. So X is equal to +6. X is equal to +6. Okay? X is equal to +6. Also give me for this one. Chromyl chloride. CrO2Cl2. Give me the oxidation number of chromium. Give me the oxidation number of chromium, please. Oxidation number of chromium. Oxidation number of chromium in CrO2Cl2. Oxidation number of chromium in CrO2Cl2. 4 plus 6. Okay. Some of you are saying 4. Some of you are saying 2 also. Wow. -6. 6 plus 6. Very good. Plus 6. Very good, beta ji. Very good. 6. Thank you, all of you. So chromium X, oxygen contain -2 charge. So +2 into -2. Chlorine contain -1s. All the halide contains -1. So +2 into -1. Total charge equal to 0. So X minus 4 minus 2 is equal to 0. X is equal to +6. X is equal to +6. Okay, give me this one. Give me for this. K2Cr2O7. K2Cr2O7. Oxidation number of chromium. Oxidation number of chromium in K2Cr2O7. Oxidation number of chromium in K2Cr2O7. Oxidation number of chromium in K2Cr2O7. Very good. 6 आएगा? हाँ 6 correct. Thank you. Very good बेटा जी. Very good. Very very good. Very good. So potassium, lithium, sodium, potassium, alkali metals. All the alkali metals plus 1. Lithium, sodium, potassium, it can lose 1 electron plus 1. So potassium 2 into plus 1 plus how many chromium? 2. I don't know that. So 2 into x plus how many oxygen? 7. Total कितना बोलो? -2 charge is equal to 0. So 2 plus 2x minus 14 is equal to 0. So what it is? 2x is equal to कितना क्या बोलो? -14 6. Sorry 14 right? Minus 12. So x is equal to plus 6. X is equal to plus 6. Now I will ask one last question and I'll confuse you. I'll confuse you and then we'll discuss tomorrow. What is the oxidation number of chromium in CrO5? What is the oxidation number of chromium in CrO5? Very good, plus 6. What is the oxidation number of chromium in CrO5? Give me this value. We'll close the class. We'll continue tomorrow. We will have very interesting concepts. Oxidation number of chromium in CrO5. 10. Rahul is saying 6. 10. Nehasri 6. 10. Minus 5 also. 10. 10. 10. Plus 6 minus 6. What is that? I don't understand. 10. Solo 5. Sriya 10. Very good. 10. Plus 5. Oh. Plus 5. Thousand. Okay, देखो इधर देखो. So x plus 2, what is the charge on oxygen? Minus 5 is equal to 0. X is equal to plus 10. कितना आ गया? X is equal to plus 10. कितना आ गया बोलो? X is equal to plus 10. But ये आंसर गए गलत. This is incorrect answer. Therefore, it's very important to understand the structure, which you'll understand later. If you see CrO5 का structure, what is the structure of CrO5? CrO5 looks like this. Chromium. You see why it is not possible. Pale, let me come to that. Why it is not possible to have plus 10? What is the configuration? Can you give me the configuration of chromium? Can you give me the configuration of chromium? Valence configuration. Can anybody give me the valence configuration of chromium? Valence configuration of chromium. Can you give me the valence configuration of chromium, please? Fast. Let me see. Valence configuration of chromium. Can you give me that? Valence configuration of chromium. Give me valence configuration. Valence configuration, if you remember, was 4s2 3d4, and this was the exceptional case. So this was 4s1 3d5. So valence electrons are 6. Yes, 6 electron, 2886, right? So 6 electrons are the valence. So 6 valence electron. 6 valence electron. And what is the maximum oxidation number? What is the maximum oxidation number? Maximum oxidation number is equal to valence electron, which is equal to plus 6. Now the valence electron are plus 6. You can have maximum oxidation number plus 6. How we are getting plus 10? How is it possible? Not possible. So whenever the oxidation number increases beyond its limit, there is something called as peroxide linkage. What is peroxide linkage? This linkage we studied, this is known as peroxide linkage. That means oxygen will not have minus 2, it will have minus 1. So if you look at the structure, this is chromium oxide structure, CrO5. This is called a butterfly structure. You will study these structures in higher classes. Now if you check, highest to 6 is possible, 6 से ऊपर जाएगा ही नहीं. How many bonds? 2 bonds. So this is minus 2 and this is plus 2. Now single bond minus 1, single bond minus 1. So due to these two minus 1 plus 2. Single bond minus 1, single bond minus 1 plus 2. So plus 4 plus 2 is equal to plus 6. Is equal to plus 6. Oxygen-oxygen bonding. Yes, oxygen-oxygen bonding. Is it clear to everyone? Is this picture clear to everyone? Just give me a thumbs up, guys, and let us close the class. Tomorrow we'll discuss very, very interesting concept. Tomorrow we'll discuss very, very interesting concept, you'll see. And we'll learn different kinds of oxidation numbers, and different kinds of redox reaction. Tomorrow we'll discuss. Just give me a thumbs up, guys. Let's close the class now. All of you understood, I hope. Okay, guys, okay. Okay. Thank you so much. Thank you so much for coming to the class. I enjoy all of your presence. Thank you so much. Thank you, Anuradha. Bye-bye. See you tomorrow. We'll continue tomorrow. Okay? Thank you.